Welcome. This is Chapter 2, Section 6 about stresses on an inclined plane. Our goals for today are to perform stress transformation so that we can understand the state of stress in a different coordinate system. This will involve finding the maximum and minimum stresses. You can imagine finding the maximum and minimum stresses are important since we've kind of already established that's how or why things break. It'll also help us find the orientation of the maximum and minimum stresses. So this lecture starts this process. It's going to be continued really over the course of the Chapter 2. That's what Chapter 2 is about. But we've got a couple more lectures about this topic that we're going to go through. The equations that we're going to need from the study guide are equations 2.7 and 2.8. I'm not going to tell you what those details are right now. We'll derive those equations and then we'll start to work with them. So but that's where we're headed. The key for this section is that the magic of stresses and strains, the magic of these things is the way that they change from normal stresses to shear stresses. And the way that they change is based on how we look at them. They are this chameleon kind of feature, and this section is going to look at that. So let's start with a tension stress. So what I mean, and if you remember in the last section, we had this thing that we push on. Oh, my pen's not working. Hold on. All right, my pen's not working, but that's okay. I think I can do it this way. We had this thing that had two eyelets, and it had it was called a dog bone. Boy, that's a really bad. And we took that and then we pulled on it. See, I can't see where my mouse is. We pulled on it that way and we pulled on it that way. Well, okay, let's not do that. Let's jump to this picture. We add a cutting plane. We take this tension, this dog bone that we had, and we pull on it where you can see where we're pulling on it. And then we add a cutting plane that's set by some arbitrary angle, theta, and we're going to want to pay attention to all that, but we're going to move over to a piece of paper because now we're going to have formulas and arrows and a lot of drawing, and I think it's going to work better on paper. So let's transition here a sec. So with the math behind us, the next thing we're going to do is an example problem. We'll do example 2.6. That'll be in another presentation. And if you're keeping track, we're going to skip sections 2.7 and 2.8. What those sections are going to do is take the principles that we just completed in 2D and apply them to 3D. But if you can do it in 2D, you can do it to 3D. It's just more math, and it's going to slow us up from making other progress. So hope you're having a great day. See ya.